In this video, I'm going to talk about equivalent fractions. Equivalent fractions are the same fractions, just using different values. So 1/3 is equivalent to 2/6. It's worth the same amount as a fraction, it's just using different numbers. It's also equivalent to 3/9, it's equivalent to 5/15, it's equivalent to 100 over 300, and so on. Okay. Let's see, how did I do this? Well, it's very simple to create as many equivalent fractions as you like. All you have to do is multiply the numerator and the denominator by the same number, or divide them both by the same number, and you found yourself an equivalent fraction. It's that simple. So just to show you how I created these four, I multiplied the numerator and the denominator by 2. Here I multiplied the numerator and the denominator by 3, by 5, by 100. I could then continue on and find equivalent fractions to these, albeit that all of them will be equivalent. So let's multiply top and bottom by 4, let's say. And what would I get? I would get 12 over 36. So that is equivalent to 3 over 9, and that's also equivalent to 1/3. They're all equivalent. I could multiply this one over here by 10. Remember, multiply the top and the bottom. So 50 over 150. Multiply the numerator and the denominator by 10. That's 5 over 15 is equivalent to 50 over 150. All this is very useful when it comes to, in particular, when it comes to adding or subtracting fractions with different denominators. Okay? You can't add fractions with different denominators until you have changed them into equivalent fractions with a common denominator. So let's try 4 over 9 and 7 over 18. Okay, these denominators are not common. Okay, a common denominator would mean where both of these fractions, this one and this one, have the same denominator. Okay, now I'm going to find a common multiple. What number did these both go into? What times table are 9 and 18 both in? They're both in the 18 times table. So in which case, I'm going to change them so that they are both fractions written as 18ths. So the one on the right stays as 7/18. The one on the left, I need to convert into a fraction over 18, into an equivalent fraction over 18. So what do I need to multiply 9 by to make 18? 2. I need to multiply it by 2. So in which case I'm going to multiply the top number as well. I'm going to find an equivalent fraction to 4 over 9 by multiplying the numerator and the denominator by 2. And that's going to give me 8 over 18. Now I can add it to 7 over 18 with no problem. And I would simplify that fraction. I wouldn't be happy leaving it like that. I'd divide top and bottom by 3 and give myself the fraction 5 over 6. Okay. So anyway, all of this was to show you that equivalent fractions are particularly useful when it comes to adding or subtracting fractions. Let's try a few more examples where I know the numerator, or I know the denominator, and I've got to find the missing part. Right, here what I'd do is, if I was trying to find something in 9ths as an equivalent fraction to 24 over 36, I'd ask myself, how, or what do I need to multiply this denominator by to make this denominator? What do I need to multiply 9 by, the smaller of the two numbers, to make 36, the larger of the two numbers? Okay. What do I need to multiply 9 by to make 36? I need to multiply 9 by 4. So in which case, I'm going to multiply the unknown number by 4 as well to make 24. And that unknown number therefore must have been 6. 6 times 24 makes 24. So 6 over 9 is equivalent to 24 over 36. What do I do here? I look for what I've got to multiply 7 by to make 42. What have I got to do here? I look for what I've got to multiply 4 by to make 20. It makes no difference that I'm now dealing in numerators. Okay. Right. 7 times 6 makes 42. So I'm going to do 4 times 6 as well. 4 times 6 is 24. So 4 over 7 is equivalent to 24 over 42. And down the bottom, 4 times 5 gives you 20. So in that case, I need to multiply the bottom by 5 as well. 9 times 5 is 45. So 4 over 9 is equivalent to 20 over 45. I could quite happily keep on generating equivalent fractions simply by multiplying the top and the bottom by the same number. So let's say I wanted to multiply the top and the bottom now by 3. I could do that. Equals 60 over 135. So this fraction, and this fraction are all equivalent to each other. Let's try one up here. Let's say I wanted to, well, let's say this time I actually wanted to divide. As long as you divide the top and the bottom by the same number, there's absolutely no problem with that. So let's say I just divide them by 2. So I'd get 12 on the top, 12 is the numerator, and 21 is the denominator. 12 over 21 is the same as 24, is equivalent to 24 over 42, and that's equivalent to 4 over 7. Easy. So that's the essence of equivalent fractions. To find any equivalent fraction, all you have to do is multiply the numerator and the denominator by the same number, or divide the numerator and the denominator by the same number. Okay, that's the end of this video on equivalent fractions.